On this 2015-2025 F150 with the 3.5 EcoBoost, P0335 means the PCM may not be seeing a dependable crankshaft position signal. The truck may crank and not start, or in some cases it may start and run using cam sensor information as a fallback. Broadly, you're thinking about a possible CKP circuit issue, sensor issue, crankshaft pulse wheel issue, or PCM-related concern. If other codes are present, check what they mean first, but keep this episode focused on the P0335 crank signal path. This is an electrical sensor diagnosis, but start with the basic system checks. Make sure the battery is fully charged and the starting system is working correctly before trusting the cranking data. First, disable the fuel pump by removing the fuel pump fuse. Turn the ignition on, access the PCM, watch the RPM PID, and crank the engine. Normal engine cranking speed is between 150 RPM and 350 RPM, and the engine should crank for greater than 3 seconds while attempting to start. For this P0335 check, a value of 0 revolutions per minute, RPM, indicates a CKP concern, and on a no-start check, a value of 0 RPM indicates a CKP concern. If the RPM PID is greater than 150, continue into the CKP physical inspection. If there is no RPM signal and the engine cranks less than 3 seconds, stop and verify base engine timing. Make sure the camshaft sensor trigger wheels are not damaged, and confirm the camshafts are rotating while the engine is cranking. Repair as necessary, clear the PCM DTCs, and repeat the self-test. For the other no RPM situations in this path, continue with the CKP inspection. Next, turn the ignition OFF and check the CKP sensor and trigger wheel for obvious physical damage. Look for contamination or debris on the trigger wheel, damage to the sensor, and damage to the wheel. A trigger wheel that is physically damaged, bent more than 1.0 mm, or has contamination on the magnetic surfaces may cause an intermittent CKP signal. If you find a concern here, repair it as necessary, reset keep alive memory, and carry out the misfire monitor neutral profile correction procedure using the scan tool. If the inspection is clean, continue through the electrical checks. With the CKP sensor connector disconnected and the ignition on, check the CKP bias voltage in the PCM. The question here is whether the voltage is between 1V3V. If it is in range, turn the ignition OFF and check CKP sensor resistance. The sensor resistance should be between 250 ohms, 1100 ohms. If that resistance is not in range, install a new crankshaft position sensor, reset keep alive memory, and carry out the misfire monitor neutral profile correction procedure using the scan tool. If the sensor resistance is in range, check the CKP harness shield ground. Turn the ignition OFF, disconnect the PCM connector, and measure between the CKP shield in the harness and the PCM connector terminal. The resistance should be less than 5 ohms. That shield is there to protect the CKP signal from outside electrical noise. So if the shield ground check fails, repair the open circuit, check for an intermittent ground connection, clear the PCM DTCs, and repeat the self-test. Next, with the ignition OFF and the PCM connector disconnected, check for a short between CKP positive and CKP negative. The resistance should be greater than 10,000 ohms. If it is not, repair the short circuit, clear the PCM DTCs, and repeat the self-test. If that passes, check the CKP circuits for an open. The resistance should be less than 5 ohms. If it is not, repair the open circuit, clear the PCM DTCs, and repeat the self-test. If that passes, check the CKP circuits for short to ground. The resistance should be greater than 10,000 ohms. If it is not, repair the short circuit, clear the PCM DTCs, and repeat the self-test. Then turn the ignition on and check the CKP circuit for a short to voltage. Any voltage present means repair the short circuit, clear the PCM DTCs, and repeat the self-test. If no voltage is present, continue to the next CKP voltage and continuity checks. Now check for voltage at the sensor. With the ignition OFF, disconnect the CKP sensor connector, then turn the ignition on. On the 3.5 EcoBoost, measure voltage between C1775 pin 3 and C1775 pin 2. You're looking for between 4.5 5V. If the voltage is in that range, keep going with the circuit continuity checks. If it is not in that range, stop this CKP sensor path and move into the appropriate circuit diagnosis. Instead of guessing at the sensor, turn the ignition OFF and disconnect the PCM connector. Check for an open by measuring resistance between C1775 pin 1 and C175E pin 98. The resistance should be less than 5 ohms. If it is not, repair the open circuit, clear the PCM DTCs, and repeat the self-test. If it passes, check for shorts between circuits. Measure from C1775 pin 1 to C1775 pin 2, and from C1775 pin 1 to C1775 pin 3. The resistance should be greater than 10,000 ohms. If it is not, repair the short circuit, clear the PCM DTCs, and repeat the self-test. If that passes, turn the ignition on and check C1775 pin 1 for a short to voltage. Any voltage present means repair the short circuit, clear the PCM DTCs, and repeat the self-test. If no voltage is present, move into the intermittent checks. For the intermittent check, turn the ignition OFF, reconnect the PCM connector, and visually inspect the CKP and CMP harness areas. Look for chafed wires or other physical harness damage that could intermittently short the CKP or CMP circuit. If you find a concern, repair it as necessary, clear the PCM DTCs, and repeat the self-test. If nothing shows up, turn the ignition OFF again. Disconnect the PCM connector and the CKP sensor connector, and inspect for pushed-out pins and corrosion. Then connect all PCM connectors and the CKP sensor connector. Make sure everything is seated correctly, and verify whether the concern is still present. If the concern is still present and the symptom is crank's no start, move into the no start diagnostic path. If the concern is still present for the rest of this P0335 path, install a new crankshaft position sensor, reset keep alive memory, and carry out the misfire monitor neutral profile correction procedure using the scan tool. If the concern is no longer present after the connector inspection and reseating, the system is operating correctly at this time, and the fault may have been caused by a loose or corroded connector. The takeaway is simple. Prove the crank signal first, inspect the wheel and sensor, then work the circuit for voltage, opens, shorts, and intermittent connector problems before making the final call. For more diagnostic training, visit stepdiagnostics.com.